Hello! Hello, everybody, and welcome to the LIUniverse. I'm Dr. Charles Liu. I would appreciate it if you would call me Chuck. Thank you so much for being here today, and we just have a wonderful podcast episode today. I can't wait to share all this cool stuff with you. Let us first begin by introducing our co-host, as always, Allen Liu. Hi, Alan.
Hello. Good to see you.
Hey.
As I'm always here. It's always good.
Yes. Anything interesting going on at this moment that you're doing?
Well, I got a new telescope, which was very fun. But
Ooh.
its mount is a little bit undersized for the actual scope, so it's a little bit wobbly. But I think I'm able to
Oh.
get some cool images and stuff anyway. So that's been fun.
Oh, that's terrific. Today's guest, I am so happy to introduce from the Rochester Institute of Technology, Dr. Jeyhan Kartaltepe. Jeyhan, hello.
Hi everyone.
I am so happy that you're here. Thank you so much for joining us. Please tell us just a little bit about what you're doing and where you are, and then we'll launch right into today's joyfully cool cosmic thing.
All right. Well, I'm an astronomer at the Rochester Institute of Technology. So I'm a professor here and spend my time teaching, doing research, working with students, and various other, institute commitments.
I
But
think
I'm
that's
excited.
marvelous.
Yeah, excited to talk about some astronomy.
Yeah, it's going to be great, and about astronomy related stuff too, because we're always not just astronomy but astronomy adjacent. But let's go right into astronomy right now, because today's joyfully cool cosmic thing is indeed very joyful and very cool and very cosmic. In fact, it's called Cosmos Web. The
Ooh.
Cosmos Web team has just released its data release 0.2. And this is data from the James Webb Space Telescope, JWST. It comes to us from about January 2023, and as well as a lot of data. It turns out, as well, Jeyhan, because, well, we'll explain that later. It is the largest scientific project ever yet to be conducted by JWST, which is really quite remarkable. And I just went to the website to try to download just the
The
JPEG file,
website.
not the actual FITS files. The JPEG file itself is like 24,000 by 30,000 pixels or something like that. And so it's like,
Oh
what,
man.
720 or 7,000? I got to do the math. Like close to a billion pixels or something. And that's just the JPEG.
Yeah.
That's already compressed from this amazing database of the deepest, coolest, largest field of deep space ever imaged with JWST. Jeyhan, please tell us about this, because we know, and I'll tell the rest of the audience, just how important you were to this whole process and creating this awesome thing.
Yeah, sure. And the first thing I'm going to tell you, which might blow your mind, is that data release is only 4% of the total amount of data we're going to be getting from the project. So,
Amazing.
Wow.
so that's the first drop in the bucket that we got back in January.
Oh
Wow.
man.
And so by we, the reason you're saying we is because you're one of the two lead investigators in this project, right? You and Caitlin Casey at the University of Texas were the ones who made this happen. I mean,
That's right.
that's just amazing. Tell us about that process. Tell us about how we actually, as scientists, get to use these amazing facilities, and then the kinds of science we're trying to achieve. Give a little bit of a taste of that, please.
All right. Well, this project overall is called Cosmos Web, and it's something that was put together by a large collaboration of astronomers known as the Cosmos Team. We started working on this in 2020, before the telescope even launched. And basically, you get together, you discuss ideas, and you have to write out a proposal that says what you want to do, what you want to look at, how long it's going to take, etc., and submit that. And then that's reviewed by a panel of other astronomers that have to rank everything and decide, what are the priorities and what are the most important things to do, especially during the first year of the telescope's operations. And so Caitlin and I co-led that effort, but we had a team of about 50 people. It's now grown to about 100 people, especially once you include students and others that are working on the project. So,
Wow.
yeah, so you can't
So,
even
so
imagine our surprise when we got that email that said the program was accepted. It was hard to believe.
Wow, it's marvelous. And you said that this students can work on this, right? And not just, PhD scientists with long pedigrees of science. Like everybody can work on these data if they are asking and if they work hard and they try, right?
Absolutely. Yeah. Students, in all honesty, often do the bulk of the work. They're the ones
Oh,
working the hardest and they're really enthusiastic and bringing new ideas to the team. So, yeah, we're always encouraging students to work with the data and work with us on the project.
oh, that's fantastic. I had the chance to talk with one of your students named Sadie, and she was telling me about a cool project that not even students but anyone can do. It's called Redshift Wrangler or something like that. Tell me about this. This is a very Western cowboy kind of themed thing for astronomy,
Yeah,
right?
yeah.
Yeah.
Redshift Wrangler is a what's called a citizen science project. So it's basically a project that's online on the internet that anyone that's interested can go and access and contribute, actual measurements that we will use for science in conducting our own analysis. And so this is a project that's specifically looking at the spectra of galaxies, so how their light is split up over different wavelengths or different colors so that we can measure precisely what the distances to galaxies are. And so that's where the Redshift Wrangler name comes from. We need to get that redshift information out of those galaxies, and
Wow.
anybody can help us with that.
Really? So Sadie has made it so that literally anyone don't have to have any science background or a degree or anything, and you can still contribute to the Cosmos
Right.
Project.
No background is necessary. So Google Redshift Wrangler, you'll find the project. Anybody can hop on. There's an introduction video where we talk about the project. There's a tutorial that walks you through what to do, and then yeah, you can jump right in and start making measurements. So it's been
Oh,
going pretty
That's
well so
awesome.
far.
Yeah,
that's
and
really fantastic.
just to get a beat in there, the reason that the redshifts can tell us about how far away these galaxies are is because the universe is expanding and the farther away things are moving farther away from us faster than the closer things are moving farther away from us, right?
Yeah, that's
Right.
right.
Yeah,
That's
that's the
awesome.
original discovery attributed to Edwin Hubble back close to 100 years ago, right? Showed
Yeah,
that yeah, it's really quite remarkable that
it's
we
a
can
cool bit of
actually do
science
that. But
there. Yeah.
yeah, well, I think one thing that I had a question about was that this data was released in the summer uh, of this year, but it was obtained by JWST in January, right? So there was a time lag. Is that just something specifically that like NASA does, or is there a reason scientifically why it takes a long period of time to get this kind of data out to the public?
No, there's a few different reasons. One is that it does take some time to process all of the data and get everything together. The other reason is that we were really busy with science and writing papers and doing other things with the data, so that takes up some time. So that's why that first data release, we aimed when we wrote the proposal, aimed for roughly 6 months after the data was taken. That's sort of a rough time frame.
Yeah,
That is often what people follow. Sometimes things take longer depending on complicated
Yeah.
aspects of the data. And in fact, we now have our next big batch of data that is
Oh,
woohoo!
much bigger than that January data.
More than 4% this time.
More than 4%. Now we're up to about 50%.
oh, nice.
Holy
That'll
moly!
that'll be our next data release,
More than 10 times
probably
more.
early November or something.
Wow. So
That'll be
so
great.
that JPEG is going to be like in the several billion pixel range, right?
Yeah, that JPEG may not be at full resolution. It may be a little more reduced. But
That's amazing. I think that's really awesome. Alan, do we have a question for Jeyhan from one of our student audience members?
Yeah, sure. So here is a question from Jonathan, and Jonathan is asking, why is there a black hole in the center of our galaxy, and how many galaxies are there in the universe?
yeah, those are
Oh,
both
two for the price of one.
Yeah, those are both great questions. We think that every galaxy, or at least every big galaxy like our own, has a big black hole in its center. And it's sort of a big question that we're trying to understand is where that black hole originally came from, right? If it came from stars that went supernova and formed black holes, and all those black holes eventually, got together and formed one really big black hole,
Yeah,
or if they formed from some other physical process in the early universe. It's really a big mystery right now.
yeah, because
Hmm.
the
Um,
center black holes, those are like loads bigger than even the ones you get from supernova, right?
yeah, millions of times bigger.
Yeah. Wow.
Yeah, they're huge. So you can have, a lot of small ones form from individual stars, but then that's still a lot of them that you've got to get together to form a bigger black hole. And of course, they can grow through other ways. They will eat gas and other material and their surroundings, but that takes time, right, for them to do that and to grow and to become big. And they are growing fast. So one of the mysteries is that we're seeing things that are already pretty massive black holes pretty early on in the universe's history. And so, yeah, it really makes you scratch your head. Like, how did these black holes get so big, so fast, so early
Yeah.
on?
That's a fun
Wow.
question.
So does that affect the number of galaxies there are in the universe now? In other words, whether or not black holes are formed first or whether they're formed second?
That is a good question. I don't know if it affects the total number of galaxies. I mean, yeah, there is sort of a chicken and the egg question there. Like, how important is having that black hole, for having a galaxy form, or is it the other way around? We don't actually know how many galaxies there are. They're kind of uncountable. There's so many of them. I think, yes, current estimates, if you take what we observe in a really deep image of the sky and estimate how many there must be over the entire sky that we can see, you're in the trillions. And so
Oh,
that doesn't even account for things that you can't see, right? That are too faint, that are even
wow.
further away, et cetera. So they're mind-boggling numbers.
Wow.
Wow. That is truly remarkable. So what is your area specifically of research, Jeyhan? Is it in the number of galaxies, or is it in the black holes in the galaxies, or is it something else?
It's a little bit of everything. So I mean, I very broadly study galaxy evolution. So how the first galaxies formed, and grew and then evolved over time to become like our own galaxy. And so that involves studying the stars in galaxies. It involves studying the black holes in galaxies because they grow together at the same time, right? As galaxies are growing, their black holes are growing. I'm especially interested in what happens when two galaxies interact with each other, smash together. They can
Hmm.
form new stars that wouldn't have happened at all. That can provide fuel that makes that black hole grow more rapidly than it would have. And so, and they're fun.
Cool.
They're just really cool to look at.
Oh, wow. So you are the perfect person for me to ask, in fact, this question, which has been bugging me ever since Star Trek V, The Final Frontier, with the original cast, okay? With James T. Kirk, William Shatner, who, by the way, I guess went up into space in a
Yep, yep.
spacecraft, like up
Yeah.
50 miles into space about a year or two ago, right?
I think he actually reached the 62 mile, the 100 kilometers.
Oh, he did? He
Yeah.
did? Oh,
He did,
man.
yeah.
Well, either way, I mean, it's just great. It's just wonderful. We saw him, Alan, you and I actually saw him at New York Comic Con
We did, yeah.
2022, just before he went up in his spacecraft. So
We have
that's
a
really good.
recording from that same Comic-Con that you can watch right now, but it
Well,
doesn't alas feature William Shatner.
yes, everyone, wherever you get your podcast, folks. Um, um, yeah, Jehan. So in that movie, Star Trek V: The Final Frontier, there is some sort of barrier at the edge of the Milky Way or in the center of the Milky Way or something that the Enterprise has to push through in
Yeah.
order to find Spock's stepbrother or something, and it becomes. Is there such a barrier actually in our Milky Way galaxy? Come on.
It's funny that you mentioned this because I actually made a reference to this in my class a couple of weeks ago, and nobody
Oh,
knew
no
what I was
kidding.
talking about.
You're a
I'm
Star Trek fan, right? I mean, you're huge. I
Yeah,
mean, I
yeah.
think, yeah.
I'm teaching a class right now called Galactic Astrophysics. So it's all about the Milky Way and what we know about the Milky Way.
Uh-huh.
And I was explaining how we don't really know where the edge is, right? We can see stars, we can see some gas, and we see some further and further and further, and eventually you don't see as much because it becomes faint and maybe there's not as much there. But it's not clear that that's really an edge; it just kind of fades off. And we think that there's a lot of dark matter in our galaxy that extends even further, and so we really don't know like where the boundary, where does our galaxy end and the next galaxy begin. We don't know. um, we do know there's no hard boundary that you would have to
Okay.
actually penetrate through, though.
Okay.
Yeah, so
So that barrier is bogus. Okay, that's
that's right.
fine.
Yeah.
But it
It's a
doesn't mean that Star Trek isn't
fictional
cool.
storytelling
Right.
apparatus.
It's
Yeah.
a story. Well,
Yeah.
yeah, I think it's fun, but um, I, of course, none of us have any problem being inspired by fiction to do science, or the other way around, right? So many science fiction writers and imagineers have used basic science as their launch point, right? Now, would you say that something like Star Trek affected your career significantly, either in the past or like as recently as this class that you were just teaching?
No, absolutely. I watched Star Trek since I was young. I watched the original series with my dad when I was little, and of course, the Next
Oh,
Generation and others as I got older. And I do think that it shaped my perception of what science is and what scientists do, and the enthusiasm people have for doing science, and just the approach, right? The logic of how people talk to each other, how they interact. So I think it influenced my social skills and upbringing and interactions, and as well as my interest in science.
that's very cool. Yeah, certainly affected my social experience. Alan, as you well know,
Yeah.
my wife, Dr. Amy Rablu, is an even larger Star Trek knowledgeable person than I am, and I might not have been
You
able
might be
to.
underselling yourself to some extent too.
Well, I may well not have been able to win her over, to convince her to spend time with me, if I had not been able to demonstrate some knowledge of Star Trek,
Yeah.
right?
An important compatibility point, I think.
Yeah, there you go.
Yes, very much so. And of course, I had to like Star Trek more than Star Wars, right?
No.
No, nah, actually, that's not true. It
Nah.
that's a quiet point that we keep low in the house. Well, how about you, Jeyhan? Star Trek or Star Wars? I mean, and we can talk in two different eras. Okay, first in the original era with Star Trek, the original series and the Next Generation, and then the first three Star Wars movies,
Yeah.
and then maybe a few more afterwards. And then like later on, like today, what's happening with the streaming services, where we're
Right.
getting a lot of new Star Trek spin-off stuff and Star Wars spin-off stuff too,
Yeah.
with games and also things like that. So give me a two-part answer to that:
No,
Star Wars or Star Trek?
I have to say I'm much more of a Star Trek person. I enjoy Star Wars, but I enjoy Star Wars the same way I enjoy lots of other things, right? It's entertainment, it's a lot of action, it's fun, but it doesn't resonate with me on a personal level the way Star Trek does. And Star Trek is an
Hmm.
entire philosophy, right? An entire way of being, way of thinking that it's very different.
Yeah, that's a really good question because um, a lot of times Star Trek is beyond technology. It's about how we should interact with other species. And by extension or by interpolation, how we might interact with one another as human beings, regardless of what groups or whatever identifications that we have, right? And so that is something that you appreciate about Star Trek.
Yeah, absolutely.
Yeah, we still have like arguments in Star Wars between species, but they're for the most part it's a pretty multi-species kind of thing, right? You've got Admiral Akbar sitting next to Lando Calrissian or whatever. It's a trap, But you also have the Klingons and the Romulans and folks like that, and the Vulcans and the humans all together in different ways. I think that's a really social kind of announcement. I don't know if you feel like there's something more to it than just sort of expressing an ideal about how maybe individuals should interact, Jehan.
Yeah, it's about how individuals should interact, how we can be better, right? How our ideals should be. Yeah, how to approach things diplomatically.
Yeah, I feel like a lot of good science fiction is really about human society and reflecting on that, especially something as utopian as Star Trek is, right? The idea of like this is how we should strive to be, even if it's not how we always manage to be.
Right. Which you see people have their struggles and they get upset and they want to do something, and then in the end they say, okay, this is actually what we should do. Right. And you see that,
Yeah,
that internal struggle play out in the
Right,
stories.
right. But then you have like totally amoral or even immoral species, right? Something like the Borg, for example, right, which is revealed not so much to be evil as we might think about it in humans, but as just totally not having our value set, like not sharing it all, a hive mind, all about their own expansion and their
Mhm.
own increase and so forth. And then how we deal with that
yeah.
becomes an interesting point, right? I
Yeah.
mean, that is there some, I don't know, do either of you feel like there's some kind of modern or current allegory here going on that I'm not picking up?
how to communicate with other groups that don't share your ideals. I don't know. That seems
Yeah,
pretty important in the modern world too.
it is. Yeah, I feel like there's a lot of stuff in there. People talk. I mean, the Borg sort of lends itself to the idea of AI and stuff, right? Where it's like,
Oh,
you
Yeah.
don't have to have an evil AI that to take over the world. You just need one that isn't explicitly good.
uh-oh. So
Well,
before you know it, we're going to have to bow down to our Chat GPT overlords. Is that what you're saying,
well,
Alan?
probably not ChatGPT specifically. Just
And just
I
have
mean,
they
yeah,
have their own goals, right? And it's not necessarily about good or evil, but
yeah,
it's just
right.
a different
That,
goal and yeah, different
that's
values.
the idea.
Yeah.
Yeah,
Hmm.
so we have to be careful there.
Okay.
Mhm.
Well, I totally get that. Um, I feel like this is a good time for another question. We have another student question, Alan, queued up.
Yeah, we got another student question. So
Excellent.
our second student question is from Cynthia, who asks, in a way, the brain has a bunch of similarities to the universe. Is there a
Ooh.
connection between the two, logically or illogically?
Oh, so right into this AI conversation here. This is like not AI, right? It's like
Yeah,
natural intelligence. Hmm.
yeah.
Yeah. I mean, I think one of the biggest similarities is just how little we know about each. Right?
Fair.
How extensive they are, how much information is contained, and how we're just, scraping the surface of what we actually know. We don't know a lot
Huh.
about the brain and how it works, right? We're still learning.
Yeah, as I say, there's a lot of the ways that we try to understand both are about interpreting the kinds of patterns we see and we can observe and what we can understand, and then trying to use those to make inferences about what we can't understand just in the general scientific process. So in that, I think both neurology and understanding the brain, and then astrophysics and understanding the universe are good examples of how science works in that way.
Sort of trying to understand the unknown of extremely complex systems, something along those lines.
Yeah, just being like, okay, well, if we know that if this part of the brain lights up, then that part of the brain lights up with that particular statistical likelihood. And similarly, we know if we see these spectral lines in a galaxy, those spectral lines in a galaxy show up with whatever frequency, and we can draw conclusions from that, right?
Yeah. Well,
I mean, EEGs and spectra look pretty similar too, if you think about it.
they do, but the brain is so small compared to the universe, right?
True.
How can you even imagine? Because heck, each one of our brains is contained in the universe. So doesn't that mean that the whole universe, Jehan, is necessarily more complex and complicated than any individual content, like any individual brain that's contained inside the universe?
Ooh, that's a good question. How do things scale when it comes to
Yeah,
complexity? Sometimes
right.
really big things can still be pretty simple, right? So it doesn't have to be that bigger is more complex. But
Mhm.
what is complex is all the different physics, all the different things that are happening, all the gas in the universe, the different chemicals, all the different interactions and things that are happening. That makes it really complex, and it's different, and maybe in some ways mirrored, right, when you're thinking about what's going on in the brain,
Uh-huh.
even on completely different scales.
Yeah.
Okay. So, but I can understand that the complexity of it being different and things like that. And even though it's similar in some things, it's very, very different in other things, and
Yeah.
vice versa. So, yeah, that makes sense. Well, Jahan, you work on you were saying interacting galaxies, right? Things that are coming together. In the cosmos field, just in the 4% that you're looking at, it looks like there are thousands, maybe hundreds of thousands of galaxies. Um, how often are they interacting and doing new things? Does every galaxy eventually interact with another galaxy and produce new results, or is this sort of a rare phenomenon?
Oh, that's a great question. I mean, over the age of the whole universe, most galaxies probably interact with something on some level.
Hmm.
We take our own Milky Way galaxy, for example. We're in the process of interacting with the small galaxies next to us, called the Large and Small Magellanic Cloud.
Oh.
There's evidence we've interacted with other small galaxies in the past because we can see streams of stars that appear to have come from somewhere else. At the same time, we're going to merge with the Andromeda galaxy in 5 billion years or so. So we think it's time before that's going to happen, but that's in our future, and a lot of other galaxies have gone through this kind of a path. So yeah, it's overall a fairly common process, but it happens on very different scales.
Wow. So we can expect in our future in an amazing interaction. Of course, most of us are not going to be around to see it, but when it does happen, uh, you're pretty sure you know what's going to happen to us, right? Based on the research that you're doing right now about interacting galaxies that you're seeing right now. I mean, what is our fate? What is
Yeah.
our future?
I mean, because Andromeda is so big, it's about the same size as the Milky Way, right? The process of that interaction is going to completely disrupt the disks of both galaxies. So, right now we have these beautiful spiral arms, right? Those spiral arms at some point will no longer exist. Um,
Wow.
Material is going to be pulled out because of gravity, and then eventually the whole system will coalesce into a, football-ish shape of galaxy of stars that we call an elliptical galaxy. So it'll be a very
Wow.
different shape and a different structure after that process.
Whoa. So, should we humans like escape as fast as possible? I mean, we've got a 5 billion year or however many billion year head start, right?
Yeah, we got a
Should we
while.
get out of here before like things get too hot for us to handle?
We've got the sun to contend with before that. the,
That's
Oh,
sun,
okay.
fair.
the sun will probably be a red giant. It'll be too hot to handle on Earth by that point. But
Ah,
if yeah, one of the weird quirks of gravity is that even though things are going to be flung all over the place and stuff's going to be happening, the Earth will still be bound to the sun, right? We're close to the sun, we have our orbit.
oh,
We really wouldn't be affected other than over long periods of time having a very different view of the sky, right? As the
Yeah.
sun would move through the galaxy.
okay. All right. Well, that makes me feel better. I don't have to change my retirement plans, right?
And any other people that are living on other planets throughout the galaxy, they'll probably be safe, during this process.
Ooh,
Awesome.
I feel much better. Oh, that's very good news. Okay. So we might still be able to discover the Klingons or the Romulans at some point in the far future, shall we say.
Yeah.
We got
Okay.
5 billion years before that anyway.
Okay. I'm glad to hear it. Now, I wanted to bring up the point that you're in Rochester, New York, right? Which happens to be in the path of totality for a
Mm.
total solar eclipse. I mean that's just a specific point, like where astronomers all over the world are now suddenly paying attention to upstate New York and things like that. But that's a nice area, right? I mean, the area where you were, you spent time there before you were at RIT, isn't that right?
Roughly. So I did my undergraduate at Colgate University, which is a couple
Ah,
of hours from here.
uh-huh. So are you a fan of upstate New York in general that you decided to come back because like it's a nice place to be? Or I'm by the way, everyone, just for full disclosure, I do not work for the upstate New York Tourism Bureau or anything like that, but I do like that area. I have been to RIT in the past, and I really like that upstate area. So tell me about the area. What do you think?
No, I do. I do really like upstate New York. I especially like the outdoors. Rochester itself is a city, but it's a small city, and you're on the lake, and there's hiking, and so you kind of have access to all the different things you might potentially want to do. So that's really nice. The seasons here are amazing. We're already starting to get fall colors. They'll be
Nice.
Oh,
great. They'll be great in a couple of weeks. So yeah, I really enjoy being in this area.
hmm. All right. So sounds like I got to get up there sometime soon. If things are already changing color, it is lovely up there. And then the eclipse is just another reason to go up. Although it's going to
Yeah.
be in April. Can you give us a good weather forecast for April 8th,
Yeah,
2024?
it's probably 50-50. It's really hard to say. That time of year, it can be very hit or miss with what the weather's doing.
I'll
Yeah.
take a chance. I'll take a chance. Okay. Well, we have so much more to talk about. I would love to continue our conversation sometime in the future. Jeyhan, will you come back, please? And we just have more. Maybe once we get the other, 50 or 96% of the Cosmos Web, you can come back and tell us about all the amazing discoveries that you have. In the meantime, can you give us like one cool discovery that you already know about that has already been published by you and your team and your class and your colleagues that really we should all be paying attention to? We should all know.
Yeah. So one discovery, that's been in a recent paper is that we're finding some examples of really bright, very high redshift, meaning very distant galaxies. So galaxies as we're seeing them in the early universe, and that are already pretty bright and massive. So these are rare, very rare galaxies to find, which was one of the main drivers for the survey in the first place.
Wow. So they're there are many such rare galaxies.
In
In other words, they're
cosmos,
not as rare.
because it's so big.
Right.
Yeah,
In
so
other
they're
words,
rare
it's
as
not
proportion, but like just
right.
because
Right.
you got so many in there. Wow.
Yeah,
Exactly.
because they're not so rare anymore. If you found a lot of them,
Exactly.
either that or they're still rare in comparison to all the others because you found so many other galaxies.
Yeah, they're rare in comparison to the others, and they're rare, spatially. So you have to cover as many galaxies as something like Cosmos does in order to find
Hmm.
a significant number of them.
How big on the sky is the Cosmos data
So
area?
yeah, so the full moon is half a degree across, and the Cosmos Web area is a little bit more than half a degree by half a degree. So you could fit a few full moons within the Cosmos Web area.
Nice.
Wow.
That's, yeah, it's
That's a
once
lot
it
of
seems
space.
like a lot, and also seems like there's so much sky out there. Oh my gosh, you know.
Yeah, absolutely.
Wow. I'm so impressed. Last throwaway final question. Okay. I got to ask you. The best Star Trek captain.
Oh,
The best. The best. I mean, I don't want any, yeah, well, they're all very good. I don't want any kind of, well, I would do
But
this.
that's the
No,
easy way to answer a
the
question.
best.
no,
The
there's
best Enterprise captain.
the Enterprise captain. You're very specific then.
Oh yeah, you're not
Yeah,
counting
I'm now
Janeway
getting
then,
to
or
Enterprise. So let's, I
It's
guess
an
if,
easy answer. It's an easy answer. It's Captain Picard, of course.
ah ha ha. Okay, everybody, the gauntlet has been thrown. All of you Kirk fans, we expect to hear from you. Jeyhan, how can we be in touch with you? How can we find out more about what you're doing and the Cosmos Web things and all those sorts of things? How can we find you?
I'm active on Twitter. It's just my first name. Jeyhan is my handle on Twitter. We have a webpage for the Cosmos Survey that you can look at. Or feel free to send me an email.
Wow, fantastic. Jeyhan, thank you. Dr. Jeyhan Kartaltepe at Rochester Institute of Technology. Go Tigers. Way to go, Jeyhan. Thank you so much for being with us today. Thank you very,
Thank you
very
for
much.
having me. It's a lot of fun.
Okay. Allen, as always, thank you so much. Awesome co-host Meister. Way to go. Thanks.
yeah, you're welcome.
And for all of you in our audience, thank you so much for being with us in this episode. If you like what you see and hear, please support us on Patreon. And as always, thank you for being a part of the LIUniverse.